Hello, welcome to the Medico Multimedia task presentation for the MediaEval 2020 challenge. The task for this year was automatic polyp segmentation, and you can see below the list of the organizers. At first, I will give you some information about the background, then about the task, the data sets we used, then I will talk about the results obtained by the participants, and then I will talk a bit about the possible conclusions we can draw from this. About the background. So the human digestive system can be affected by a lot of different diseases. For example, polyps, which are the stage before cancer, there can also be worms, bleeding, and so on. If you're able to detect these lesions really early, then you have a good chance to be healed. So the earlier you detect it, the better. For example, if you detect polyps early, you will maybe not get cancer. The gold standard at the moment for this is video endoscopies. So a doctor takes an endoscope, puts it inside you, and tries to find these abnormalities. This, of course, depends a lot on the skill and expertise of the doctors. And they also have often a quite high miss rate. Okay. So what was the task this year? The task one was segment colon polyps. Why colon polyps? Because they are among the most critical findings. That means if you can find a polyp before it gets cancer, you can basically save lives. That's why it's really important to find them early. The evaluation metrics we used for this task were precision, recall, dice coefficient, and the intersection over union. To rank the submissions, we choose the intersection over union, also called IOU. And the second task was efficient segmentation. And the goal of this task was to do this segmentation as fast as possible so that it could maybe be used in a real-time scenario in the hospital. The speed is measured in frames, and the participants were required to submit the Docker image. The performance of all participants that sent the Docker image were evaluated on a standard PC with a NVIDIA GeForce GTX 1080. So for the development stage, we had the dataset that we shared, which was the Quasir segmentation datasets, which can also be accessed via datasets.simula.no. It contains 1,000 segmented polyps, meaning the images of the polyps and the segmentation masks. You can see some examples here below. For the test dataset, we had 160 additionally collected polyp images just for this task that were all segmented and verified by experienced endoscopists. So some statistics about the participants. In total, we had 32 registered teams, 18 teams that submitted in total, 18 out of these 18 for task 1 and 10 out of these 18 for task 2. We had 17 teams that at the end submitted the task description paper. We had 41 submissions for task 1 in total, different runs. We had 14 submissions for task 2. So that means different runs, participants submitted. And it looks like all of them used deep learning, which is not really a surprise. So the results for the polyp segmentation task. So based on this official score that we choose for the challenge, which was IOU, the first team is PRML 2020 GU with a score of 0.789, followed by AI minus TCE with 0.777. And then on the third place, HGV ACMUS with 0.765. What we can see with all of them is that they are quite close. So there's no one that is really outstandingly outperforming the others. If we look at the other scores that we calculated, the best dice score was achieved by the team PRMLL 2020 GU. The best recall was by AI TCE. Best precision was by II MET. And the best accuracy was by PRML 2020 GU. There were two teams that were not taken into account for the ranking because task organizers were in the teams, which is the team VT and the other HB, KU, UNIT, M, and similar. Here we see a graphical overview of all the results. This contains all the submissions for all the teams. And yeah, we can see that it ranges quite a lot from below 0.2 up to 0.8. The results for the polyp segmentation efficiency are presented now. So the best teams sharing number 1 is HCMUS and FAST NUDS, followed by on the second place SBS. The top teams, they have an IOU above 0.7, which we used as the threshold, and the frames per second about 25, which is kind of used in industry as the standard. The fastest team was George Batch with around 200 frames per second and an IOU of 0.635. Here we can see how the different submissions performed, taking IOU and FPS into account. And what we can nicely see here, that there is a kind of correlation between how accurate you get to how fast you get. So the faster you get, the more precision you lose. In conclusion, there was an overwhelming interest in the task this year. So we had 32 people that registered, or teams, and 18 that submitted something, which is quite nice. We got a lot of different and really nice approaches submitted, which are interesting to read and also see the performance. So all the participants got really good results, you can conclude, but it's still, the IOU is still below 0.85, which we kind of see as a threshold that should be achieved for clinical use. Again, as concluded before, there's a clear relation between speed and segmentation performance. And it's kind of still a challenge. So I hope we will have another iteration of this task. Thanks a lot.